Question 2, part A. What special name is given to shape E? Circle your answer. So this is shape E here. It has 1, 2, 3, 4, 5, 6 sides. So that means it is a hexagon. And that is 1 mark for that question. Part B. What special name is given to shape B? Circle your answer. Shape B is here. It gives you a little clue by using these lines. They mean that these two lines are exactly the same and the angles below are exactly the same. It's a special kind of triangle called an isosceles triangle. This isn't part of the question, but if you see here, this triangle has 3 lines, on a line on each of the 3 sides here, which means that the 3 sides are equal and the 3 angles are equal, also giving us a clue being that that is an equilateral triangle. As I said, that's not part of the question. So we get 1 mark here for circling isosceles triangle. Part C. Circle either true or false for each of the following statements. This is a 2-mark question. This can be quite tricky because you need 4 correct answers to get 1 mark, and you need all 5 correct to get the full 2 marks. Okay, so shape A is a pentagon. Shape A is here, 1, 2, 3, 4, 5 sides, which means that is a pentagon, so that is true. Shape B has a pair of parallel lines. Parallel lines mean they're nice and straight. They will never ever meet. They won't touch at all. So shape B does not have any lines that aren't touching. So therefore, that is false. Shape D has 2 sides that are perpendicular. Perpendicular means that the 2 lines meet at a right angle. Shape D is here, and these 2 lines, we're told that they do meet at a right angle, so those 2 lines are perpendicular, so that's true. Shape E has 6 lines of symmetry. So a line of symmetry is where we can cut a shape so that it is perfectly symmetrical on both sides. So I'm going to have a look at this shape here. I'm going to look at the vertices, which are the corners, and if I draw a line here, this side is perfectly symmetrical to that side, so that there is 1 line of symmetry, and I can do exactly the same throughout the rest of the shape. This side is perfectly symmetrical to that side. This side here is perfectly symmetrical to that side. Now I'm cutting it right in half. This side is perfectly symmetrical to that side. This side here is perfectly symmetrical to that side. This side here is perfectly symmetrical to that side. So that gives me 1, 2, 3, 4, 5, 6 lines of symmetry. So obviously these are the other half of the lines I've just said. So that there is true. So we have a 6-sided hexagon which has 6 lines of symmetry. Shape A has no lines of symmetry. So shape A is this pentagon here, and as you can see that is incorrect, because if I put my ruler here and draw a line of symmetry, this side is exactly the same as that side. I can do the same here. This side is exactly the same as that side. and so on. So I have 1, 2, 3, 4, 5 lines of symmetry here. 5-sided pentagon, 5 lines of symmetry. So this question here is false.